All right, we're going to use our substitution and elimination practice here and have you guys check your work if you would like to do that. So you have a couple examples at the top of the page on how substitution works and how elimination works. We've talked about those the last few days. The first set of problems here says, look at each system below. Which solving method seems to be best to use for each of the systems and why? I'm going to have a ton of space here, but let's see if we can write some of this in. So in the first one, you'll notice that the second equation is solved for y. And with that type of situation, we want to use substitution. So if you have an equation that's either solved for x or solved for y, then we take what's after that equal sign, we circle it, and then we draw an arrow up to the first equation, and we would substitute it in for y. So that's like trading out like a $5, four $5 bills for a $20 bill. They're equal to each other, so you can replace one with the other. You can trade it out. So substitution the second equation is solved for y. In other words, it's got y by itself, which makes the substitution step a little easier. All right. B, if we look at that one, notice neither equation is solved for x or y. We don't have x or y by itself. But what we do notice is that we have these y terms right here that are both 6y. They both have the same coefficient. And that means that we can use the elimination method. And if we think about how that elimination method would work, remember, when we're eliminating, we're either adding or subtracting the x values and the y values. And in the process, we want them to cancel out to 0. We want one of the sets of variables to cancel out to 0. So in this case, if we subtracted 6y minus 6y, that would be 0. And so you would subtract the x values, you would subtract the constants at the end on the other side of the equal sign here as well. So that's how elimination will work. You're looking for two of the coefficients to one of the variables to be the same. So in this case, 6y, 6y. So both coefficients, that coefficient is the number in front of the variable. So both equations for y allow the equations to be subtracted to eliminate a variable. Okay, and we don't have to solve these, we're just talking about what we would do. All right, and C. All right, so this one is not solved for y. We don't have y by itself. When it's not solved for x, we don't have x by itself. And we don't have the same coefficients in front of either the x or the y, like 4x and 2x. We don't have the same number there. 3y and 1y, we don't have the same number there either. So this one's kind of in between. It's kind of like, all right, what would you choose? Now in this case, what we may need to do is what we did up here in the example for substitution, in that you have the same sort of situation in which you don't have one of the equations solved for y or for x, but you can change one of the equations to make it into an equation solved for y. And that's what we would do here. In the second one, we'll notice that 2x plus y equals 6. So if I subtract 2x from both sides here, if we subtract 2x from both sides, then we rearrange the equation. So now we do have an equation that is solved for y, and now we can do that substitution step. So in this case, substitution probably would still be the best way to go. So substitution, we can solve the second equation for y and substitute. All right, let's look at D here. Let's see, once again, let's think about substitution. Is one of the equations solved for x or for y? In this case, yes, the first equation is solved for x. We have x by itself, which means that we can take what's after that equal sign, the 5y plus 2, and we can substitute it into the second equation. Since x is equal to 5y plus 2, we can substitute that 5y plus 2 in for x. So once again, substitution. The first equation is solved for x, then substitute. All right, E. Are either of the equations solved for y or for x? In this case, we have neither of those are solved for y and for x, but we do have then the elimination. We look at the x values here. We do notice they have the same coefficient, although one is a negative and one is a positive. And so in that case, we are going to get them to cancel out to eliminate the x values. We would add the equations together, and that would eliminate the x values. The y values added would end up being, what, 37y, and then we could add these together to get negative 370, so we could solve that. But in this case, elimination then. We can add the equations to eliminate the x, and then solve for the other variable. And then F here, once again, we don't have either of the equations solved for x or for y, and so now let's look at elimination to see if we have the coefficients the same, and yes, we actually do. Actually, in both situations here, we've got a 1x, we have got a 1y, and then a negative 1y. So in this case, you could either add or subtract. If we were adding, that'd be probably my preference. If we add the y's together, that would cancel out to 0, that would eliminate the y's, and if you decided to subtract, subtracting would actually eliminate the x's instead. So you could go either way with that, but in any case, it is elimination. If we add the equations, we can eliminate the y. And likewise, if we subtract the equations, we could eliminate the x. So that's kind of how you're thinking through those problems.